No, actually, I'm going to broadcast it to your parents if I have to yell at you. All right. So we're talking about constant rate of change. Let me go ahead and call out a couple of kids right now so that their parents can hear them on the video. Constant rate of change. When we're talking about constant rate of change, we're talking about a function that is considered to be a linear function. If you see inside the word linear, you see a keyword line. It's because when it's graphed, it's going to form a line, or as you guys like to call it, a straight line, which by definition is what a line is. It's straight, has no curve to it. So a linear function is a straight path that it consistently is increasing by this common rate of change or a constant rate of change. Kenston, hush your mouth, please. That's your only warning before I kick you out. So what we're looking at today are linear relationships versus nonlinear relationships. So is it linear or nonlinear for the function that's stated there? Again, to be a linear relationship, it has to have a constant rate of change. So the constant rate of change is found by taking the constant change that occurs for your y over the constant change that occurs for your x. That's what makes it a linear relationship. Now, for a few little reminders, when we're talking about tables, the way a table is set up, if it's set up as a vertical table, your x is on the left and your y is on the right. If it's set up as a horizontal table, your x is at the top and your y is at the bottom. That's the way that the setup is for tables. Obviously, if it's for a graph, you also need to make sure that you understand that when you read a graph, you read it from what to what? Left to right. Good. So make that as a keynote as well, that you read a graph from left to right. So when you're looking at one point to the next point, you start at the furthest most point on the left side and work your way all the way to the right. So sometimes your points might be decreasing in value when it comes into terms of the y, known as a negative relationship, versus sometimes it might be increasing in terms of y, known as a positive relationship. Okay? All right, so taking a look here, we're going to do the first two problems together, and you'll do the third one on your own. We're going to identify if it's a linear relationship, and if it is a linear relationship, then we need to identify what that constant rate of change is going to be. And for right now, we're just going to label it an ROC, my rate of change. All right, so taking a look at the very first problem. Again, this is a vertical table. That means that my x is going to be on the left side. My y is going to be on the right side. So the first thing that I want to identify when I'm trying to find my rate of change, to see if I actually have a rate of change, I want to identify the change for my y, which means how is my y going from point to point. So if I'm starting at 10 and going to 18, what's happening there? Connor? Adding 8 or increasing by 8. What about from 18 to 26? Adding 8 again. Going from 26 to 34, adding 8. So our change of our y is a positive 8. Now we're going to put that over the change of our x. So looking at our x values, going from 1 to 2, what's happening there? Plus 1. 2 to 3 is plus 1. 3 to 4 is also a plus 1. So our change of our x is a positive 1. That means that we do have a consistent change, a constant rate of change, which is going to be equivalent to 8 over 1 or just 8. Because we have a constant rate of change, it is considered to be a linear function. Okay, if we take a look at problem B, Again, we have to look at specific points that are occurring here. So I'm going to go ahead and detail these points out a little bit larger so you can see them easily. Again, I said before that you start by reading the graph from left to right. So you focus on the point that's the furthest to the left, which happens to be this point right here. Our change of our y's means that we're focusing on the y-axis. So from this point to the next point, we're decreasing in value. What did we decrease by? 20. Not by 2. 2 would be the grid. You want to focus on the graph, not the grid lines, but what the graph represents. If you're looking at your axes, the y's, each box is a decrease of 10. We go from 80 down to this line, that would be 70, down to the next line, that's 60. So it's decreasing by a total of 20 here. Same thing for the next point. From this point downward, it is also a decrease by a total of 20. So that means in this case, our change for our y is a negative 20. Then we focus on the x's. Again, not the grid, but what the graph is talking about. So you have to look at the axis. So starting from here to here, we're increasing from 8 to 16. That's an increase of how much? 8 points, right? Or 8 volunteers based off of what the x represents. Then going from 16 to 24, that also is an increase of 8. So that means our change of x is an 8. So then our constant rate of change, or our rate of change, is negative 20 over 8, which can simplify to negative 5 over 2, or negative 2.5. From this point on, you do not want to write it in mixed number form. Improper form is the best. Sometimes they might have it as a decimal as well. Since we do have a constant rate of change, that means that this is a linear function. Try C on your own. Identify if it's linear, and if it is, what is the constant rate of change? All right, problem C. Is it linear or nonlinear? Nonlinear, because it doesn't have a constant rate of change. So if you're looking here for the y's, it first decreases by 5, and then it decreases by 4, and decreases by 4 again, which that's fine. But the problem is that this not being consistent, while the x is consistent, it's increasing by 5 every single time. That's where the problem is. It's okay to have non-consistent values as long as the other side also has non-consistent, and they're both non-consistent in a proportional manner. But here, when one is not consistent while the other one is, then that means you don't have a rate of change. So there is no rate of change or constant rate of change. That means that it's not linear. Now, what I was saying before, that it's okay to not be consistent all the time, let me show you what I mean. So if I have a, let's say that we have a table. You don't need to copy this down, but I just want to show you. So if I've got negative 4, and then a negative 1, a 0, a positive 5. Let's see here. And then for the y's, we'll have a negative 11, a negative 2, a 1, and a 16. So if I'm taking a look here, my y, to go from negative 11 to a negative 2, I'm increasing by 9. From negative 2 to 1, I'm increasing by 3. And then 1 from 1 to 16, I'm increasing by 15. So none of those are consistent, are they? If I look at my x, to go from -4 to -1, I'm increasing by 3. To go from -1 to 0, I'm increasing by 1. When they go from 0 to 5, I'm increasing by 5. None of those are consistent either. But it happens to be that this is a linear relationship because 9 over 3 and 3 over 1 and 15 over 5 are all equal, aren't they? What are they all equal? 3. So because they all are proportional to each other, they're all equivalent ratios, this is technically a linear relationship when you graph it. Okay? All right. Let's take a look at the bottom. Talking about proportional linear relationships. For proportional linear relationships, in order for it to be a proportional linear relationship, not only does it have to be a straight line, right? It needs to be straight, and it needs to pass through the origin, which is what point? 0, 0. Good. Has to be a straight line, has to pass through the origin at 0, 0. So when we're looking here, we're looking at the relationship. We want to determine if it's a proportional linear relationship. So does it have a constant rate of change, and does it pass through the origin? First things first, I know it passes through the origin because right here it's 0, 0. All right. Now we need to see if it has a constant rate of change. So we're going from 9.8 to 19.5, or sorry, 19.6. What is that an increase of? 9.8. Then from 19.6 to 29.4 is also an increase of 9.8. 29.4 to 39.2 is also an increase of 9.8. 39.2 to 49 is also an increase of 9.8. So we have consistency for our x. This is going to be our x value. Although no, this table is written in the reverse. Time is always going to be in the bottom. So this table was written in reverse. That won't always happen. Whenever it's not labeled, you'll know that the x needs to be on the top. But for some reason, we reversed the table here. All right. Our time is increasing consistently by what? 1. So we're increasing by 1 each time here. So then that means that we have a constant rate of change of 9.8 over 1. So we know that it's linear, and we know it passes through the origin, so that makes it proportional. But we still want to graph it to make sure that it looks nice. All right, so if we graph each of the points, the one thing that you want to make sure is when you're looking at how to graph it and labeling your points, I know I need to get up to at least 49. There happens to be 14 lines here. So I need to make it, I want to make it small enough that I can at least get just past 49. So what I'm going to go ahead and count by then, if I count by 4s, it'll just make it. So if I do 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, and 56. It'll just make it past that 49 mark. At the bottom, I've got a wider girth to be able to play around with. I only need to go up to 5, so I'm actually going to skip every other line. 1, 2, 3, 4, 5, 6, and 7. Okay? And then just plotting the points. I know that I started at the origin at 0, 0, that being my first point. Then we're going to 1 and then 9.8, which is going to be roughly very close to halfway between the 8 and the 12, almost at the 10 mark. 2 is at 19.6, so it's pretty close to the 20, almost right on the 20. At 3, we're at 29.4, so it's very close to what 30 would be, which is almost halfway between the 28 and the 32. At 4, we're at 39.2, so it's very close to the 40. And then at 5, we're at 49, so that's almost halfway between the 48 and the 52. Okay, and then of course you always want to have a nice straight edge to be able to connect them all together. Usually like a ruler, which I apparently have lost mine, so we're going to use Post-it notes instead. And there we go. Nice straight line, passes through the point and the origin. Any questions about that? All right, go ahead and try the next two problems on your own on the back. Plot the points, find the constant rate of change, identify if it's proportional or not. Email.